Just go back and explain how you got the 2.26. Like I understand the t-stat.
Yes. So you're just going to be using the t-chart.
Right.
And so degrees of freedom, that's n minus 1 when you have a simple regression. But really n minus 1, so that's, you're subtracting 1 for every beta you're estimating, basically. And so actually, in simple regression, it's going to be always n minus 2. But when we were just doing hypotheses before, we were just estimating one thing. So it should have been n minus 2, actually. So it would be 8, and I have the wrong number here. And then you go over to, if you're doing a two-tailed test, it would be at the 95% level. You divide 5 by 2, and so that's how you know to go to t with the subscript of 0.025. And so then you would go to where those two numbers meet, and you have 2.31. So that's what I really should have here. So your degrees of freedom is always going to be n minus the number of betas you're estimating. And here there's the intercept and attendance, which is why it's 2.
And did you do that just so we could see it more clearly, or do you need to do this?
You don't need to do this because you're given all of it.
Because it all comes out
in the table. But this is just what
it means.
Computer did, basically, which you don't have to do anymore.
Okay.
When you're running regression.
What makes this a two-sample test?
A two-tailed test?
Well, when you subtract by 2, isn't it a two-sample test?
When you subtract by 2, it means you're estimating 2 beta coefficients. And so
Okay.
we're estimating the intercept, which is beta naught, and attendance, which is beta 1. And so since you're estimating 2 numbers, you subtract 2 from the sample.
Okay.
Yes. But you are always doing a two-tailed test. So the regression is always doing a two-tailed test because it's just saying beta is equal to 0 or it's not equal to 0. So it could be greater than or less than 0 to be rejected. And then with confidence intervals, you're always doing two-tailed as well because you're getting the lower number and the higher number. So hopefully that makes sense. Okay. And then any other questions before we go on to part E? So part E is based, it says if there are 10,000 people in attendance one day, how much do we predict will be bet? And so for that, we're just plugging numbers into our model. Well, I'll just do it over here. So our regression output can be put into equation form. And so that would just be, you would have bet amount is equal to beta 0, which is the intercept, so 0.47, plus beta 1, which is 0.0146, times x, and then you add an error term. Well, you add an error term for the model. And so that's what you have, and so it's basically telling you in part E that your x value is going to be $10,000, and so we're trying to predict the bet amount. And so basically you just plug in 10,000 there, and whatever that equals is your prediction for bet amounts. And so that would be your answer. So does that make sense to everyone? Okay.
And so it's always like your y variable equals b naught plus b1 times your x variable?
Yes. Okay. So that is all of number 2. Number 3 is exactly the same, and we're going to go through it, but this time I'm going to ask for you guys to interpret things and stuff. data set for this one as well. Well, so I kept performance the same, I think, and changed training. Okay, so for doing the scatter plot and regression, which is going to be our x variable and which is going to be our y variable.
Performance is y. Training is, no.
Yes.
Performance is y. Because
Yeah,
it's x
performance-
affects y.
Performance is y and training is x. Yes, that is correct.
Can you put the letter again?
Yes.
Thank you.
So performance is y.
Performance is y. Training is x because, yeah, x affects y.
Yeah, because your performance is not going to affect
Your training.
your training. It could affect like your
Later.
future training. If you did really poorly, it might motivate you to train, but this is prior training to after performance. Okay, and so remember to hit labels if you highlight the label, and line fit plots to get the scatter plot at the end. Okay, and then to make this easier to read, again, I'm going to delete red. And add a triangle. Okay, so we can see pretty clearly that this data doesn't fit our line as well as the last equation. But still, we see that there's a general upward trend. And this might be just because I changed the data, like I didn't look at how he had it, but there's definitely this weird non-linear thing going on, which is kind of strange. But, yeah, so you would definitely want to comment on those things when you're talking about the scatter plot and how well it fits the line. And so it's a little bit more spread out. There's the possibility that there's a nonlinear trend there, but you would also want to say we don't have very many data points, so with more data that might not be the case. It might just be a weird sample. And so that's kind of how you'd want to talk about that scatter plot. But generally you can see that there is a slightly upward trend. Okay. And then, so we want to interpret the meaning of beta naught and beta 1. So does someone want to try to interpret beta 1, or beta naught, so the intercept, and what that means? I'll make that easier. Yeah.
That's the 9.366.
Yeah.
It's saying that if you didn't have any training, you would still be performing at that level.
Yes. And so, I mean, he doesn't really explain what these, oh, so it's performance time.
A factory
Oh, the
workers.
factory line workers. Okay.
Okay,
So-
so that would be your performance time if you had 0 hours of training.
Right. Yeah. That's exactly right. And so, we don't really know if that makes sense or not because we don't really know how hard being a factory worker is, and maybe it is something you could come in at this relatively low level. So you can't really say for that one how much it makes sense, but you would say the model estimates that with 0 hours of training, you would still perform at a 9.3